Hello friends, welcome back to a channel that is JEE Physics. So today we are going to solve the OG problem in JEE Advance 2026 paper 2 question number 4. Now there are a lot of discussions going around this question, but this is a really an elegant question which can be approached from multiple directions through multiple different methods. So I will be solving this question through 3 to 4 different kind of methods. First one is the most straightforward one that I'm going to show you. In the next part I will come with some other discussion. And in the third part, I will show you what else can be developed from this particular method. So here they are clear cut talking about a central force field. So F vector R they have given to be minus K by R square into R cap. So generally these kind of forces we call central forces, and the property of one of the property of the central forces is that angular momentum is conserved. Although we will develop right now in detail, but one very simple straightforward derivation you can do, that if you express this force Fr is equal to, we can simply write it minus K by R cube into R vector. If you do R cross F, so here it will become minus K by R cube R cross R. R cross R becomes 0. So R cross F that becomes 0. R cross F is nothing but torque becomes 0, so dl dt it becomes 0, so hence angular momentum become constant. So this is the simplest proof of conservation of angular momentum for a central force field. But let us dip down a little bit and try to understand the situation. So here I am taking one radius vector like this, right? So essentially if I take a point over here, it can be designated as a coordinate r comma theta. So please look at it. R vector can be written as r into r cap. Here, before going forward, I am going to define two quantities. One is called a radial unit vector. Radial unit vector r cap is defined as del r vector by del r by modulus of del r vector del r. So if you look at this, if this angle is theta, clear cut r vector we can write r of cos theta I cap plus sin theta j cap. So r cap will come cos theta I cap plus sin theta j cap. Now the tangential unit vector theta cap, it can be denoted as del r del theta by modulus of del r del theta. It is basically showing the rate of variation of this particular radius vector rotation in terms of rotation. So this will become minus sin theta I cap plus of cos theta j cap. So please keep these two things in your mind, right? Now I will differentiate this quantity. So if I want to get v vector, what I am going to get, I am going to simply write them as d dt of r vector. So d dt of r vector will give you two things. We will get dr dt r cap plus r d dt of r cap. So here this is going to be written as r dot r cap plus r. This quantity over here I am going to change a little bit. I am going to apply the chain rule over here. So I will apply d theta r cap into d theta by dt. So this is going to coming r dot r cap plus r. D theta of r cap is going to give you theta cap, and d theta dt is the theta dot. So theta dot into theta cap. So this is the velocity expression that we get. Please pay attention. Every step is very, very important. So be careful about this. Here single dot means we are denoting one-time differentiation. Further, we'll proceed to calculate the acceleration part. The acceleration will become dv dt. Please pay attention. dv dt will be equal to d dt of r dot r cap plus r theta dot theta cap. So how many terms will come? First quantity will be r double dot r cap plus r dot d dt of r cap plus, now here first quantity r dot theta cap, second is r theta double dot theta cap, third is r theta double dot d dt of theta cap. This is going to come. Now let us rearrange. Please be careful. First quantity I am keeping as usual, r double dot r cap plus r single dot. D dt of r cap we have already done. Okay, d dt of r cap we have done over here. So this is nothing but it is going to come, d dt of r cap is going to come theta dot theta cap plus third term as usual, r dot theta cap. Next one is r theta double dot theta cap plus r theta dot. This is going to come d dt of d theta. I can write d theta of theta cap into d theta by dt. So I am going to get r double dot r cap plus 2 r dot theta cap plus r theta double dot theta cap plus r theta dot d dt of d theta is nothing but it is going to become minus r cap. From the previous definition you can easily check it out, and this is theta dot. So if I rearrange, it is coming r double dot minus r theta dot square r cap plus r theta double dot plus 2 r dot theta dot into theta cap. That's what the result is going to come. This is the acceleration that we are going to get. So here I will rewrite the acceleration term. Acceleration is equal to r double dot minus r theta dot square r cap plus r theta double dot plus 2 r dot theta dot into theta cap. So this is my acceleration term over here. In this acceleration term, you can clearly check there is one radial term and there is one cross radial term. So if I want to write the force over here, force is equal to m into a, which can be written as fr into r cap plus f theta into theta cap. How much fr going to come? Fr going to come mass m into r double dot minus r theta dot square, whereas f theta becomes m r theta double dot plus 2 r dot theta dot. Since we are talking about central force and the force is given here, you can check r cap. So that means the second term, this term has to be 0. Now it leads to something very interesting. You can check readily here. If I write m r theta double dot plus 2 r dot theta dot is equal to 0. Little bit of rearrangement, we can write d dt of this quantity is nothing but r square theta dot, that is equal to 0. So if I take it inside the bracket, d dt of m r square theta dot, that is equal to 0. M r square theta dot is nothing but angular momentum, right? So that means it becomes dl by dt is equal to 0. It gives L is equal to constant. Pretty interesting, very nice, right? So now let us concentrate completely on this particular term, that is a radial term, right? In this term. So here if you focus, m r double dot minus r theta dot square, as per the question, this is given as minus k by r square. Now we will proceed with this one. Please check. So I can write m, r double dot means acceleration a. I will throw it to the other side. It becomes m r theta dot square minus k by r square. Please notice L is equal to m r square theta dot. This is equal to this. So acceleration becomes r theta dot square minus k by r square, right? So far so good, correct. Now here I need to rearrange the term a little bit. What kind of rearrangement I will do? I will put the value over here. Yeah, yes. The value that we want is, what is the value of theta dot over here? Theta dot is equal to L by m r square. Let us substitute. So here A becomes R, L by m r square whole square minus k by r square. So A becomes L square by mr cube minus k by r square. So this is the acceleration term, common expression for the acceleration that we are going to get. Please understand, for equilibrium position, we take force is equal to 0, hence acceleration is equal to 0. So L square by mr cube is equal to k by r naught square. Hence r naught value that we will get from here is equal to L square by mk. We will be using this result later. Alright, so we got the value of r naught is equal to L square by mk, right? Okay, so there is one silly mistake over here. Here, this acceleration will become m into a, so it will become m into r square. So this will become m into r square. So this will become m square. This is m. So eventually it is m square m. There is no loss of generality. One m is contained. R is equal to this. So anyway, let us proceed. So how much a is equal to we got? A is equal to we got L square by m square r cube minus k by m r square. We are going to extend the or disturb the particle from r to r naught plus delta r. Perturbed, small disturbance is given from the equilibrium position. So now the acceleration term is going to look like L square by m square r naught plus delta r whole cube minus k by m r naught plus delta r whole square. So I'll just show you the process. So here L square by m square r naught cube you take common, 1 plus delta r by r naught whole cube minus k by m r naught square you take out, so 1 plus delta r by r naught whole square. So this will become L square by m square r naught cube 1 plus delta r by r naught whole to the power minus 3 minus k by m r naught square 1 plus delta r by r naught whole to the power minus 2. So there L square by m square r naught cube 1 minus 3 delta r by r naught minus k by m r naught square 1 minus 2 delta r by r naught. This is by binomial expansion. Rearranging the term, L square by m square by r naught cube minus k by m r naught square plus inside the bracket we are going to get how much? We are going to get minus 3L square by m square r naught to the power 4 plus 2k by m r naught cube into delta r. By condition of equilibrium, this is equal to 0. So how much acceleration is left with? It is left with minus 3L square by m square r naught to the power 4 plus 2k by m r naught cube into delta r. So let us go through the calculation that we have already done. So here you can check that r naught is equal to L square by mk. So if I have to replace the value of L square, so we will replace this, we will get minus 3. L square means how much? mk r naught. It is equal to mk r naught by m square r naught to the power 4 plus 2k by m r naught cube into delta r. One m cancelled over here, where r naught is cancelled. So it is minus 3k plus 2k. So we got our desired equation. Wonderful. So this is minus k by m r naught cube into delta r. This says the story. We are almost at the end of it. So here we can clearly check we got the condition that A is proportional to minus of delta R. Which one is the condition of SHM? So comfortably we can write this. Here we got omega square is equal to k by m r naught cube. So omega is equal to, we got under root of k by m r naught cube. Omega is nothing but 2 pi by t, that is equal to under root of k by m r naught cube. So t becomes 2 pi under root of m r naught cube by k. So now let us replace the value here. K is equal to, we can write L square by m r naught. So if I replace the value over here, 2 pi by under root of m r naught cube by L square by m r naught. So this will go up, there will be a square term, so it is coming out 2 pi m r naught square by L. So again we have to just replace the value of r naught, 2 pi m by L. R naught square, R naught means here, you see we have already got this result over here. R naught is L square by mk. So L square by mk whole square. So this gives you 2 pi m by L, L to the power 4 by m square k square, which gives the result t is equal to 2 pi L cube divided by m k square. So this is the time period for the corresponding situation they have asked for. So this is one type of derivation that I have done. I hope you have enjoyed. It is a bit rigorous. You have to stick to it. If you have understood, if you have enjoyed, do like, share and subscribe. I'm shortly coming up with one more idea of tackling the question, and then again one more video will be done. What else we can figure out from the same kind of approach. Thank you so much. See you next time.